Okay, a few people have had some trouble opening up the file while they're connected to the VMware client. Um, so the idea is, so you've downloaded the file that is the women's clothing reviews text data set onto your local machine, that is your laptop, and then you can't access it when you're connected to the lab machine through the VMware Horizon client. So I figured out, I think I've found out what the problem is, and I want to try to just create the short video so that we can get around this technical hurdle and get back into the actual data mining part when we meet next Tuesday. Okay, so here's the basic idea, the the basic problem. So some of you were here. Uh, I'm actually, you can see from this up here that I'm connected to the lab machine. So this is not my local machine. If I minimize this, this is my local machine. But when I'm here, I'm actually in the remote machine. And so you were here and you launched Jmp Pro and then went to go to open, and you just saw these options. And they didn't really make it clear if this was the lab machine or if this was the local, your actual laptop. Um, but if you tried to click on this PC, whatever you clicked on, you kept getting this message. So I think maybe some of you downloaded it to downloads, and then you kept getting this, and there's frustration. So this H drive, which is a remote drive, it's kind of a storage area network that Radford provides. I don't know if you use this. A lot of people are using the OneDrive, and I'm not sure if this is the same thing, but one option is that, but I want to show you how to get around this problem. I'm going to just close Jmp. So the same thing happened if you were here in the Explorer. No matter what you went to, it just gave you the same problem. Okay, so what I'm going to do is disconnect from this session and then go back into the VMware Horizon client. And I'm just going to delete this server because once your permissions are set up, you can't go back and change them. But if I make a new server and make it virtuallab.radford.edu, same as before, just log in. Okay, now at this point, before you actually connect, this is where you need to set these permissions. So I'm going to right-click on this and then go to Settings. And notice there's an option here for sharing. And so by default, my local machine, my laptop, doesn't make any folders available to the virtual machine, the lab machine. So I'm going to click here. And so notice by default, it makes my user home drive, that is, C users rgrus. So I'm going to be able, when I set this option, I'm going to be able to access this folder when I'm connected to the remote machine. So now with that in place, so this folder is going to be visible, but nothing else. So I need to make sure that the file that I download is somewhere in here. And it is. I put it into a directory underneath here, which is called text data set. So I'm just going to show you. Okay, so once I have that setting, I double click and connect. And after I show you, I'm also going to show you what to do about some local issues. Maybe while that's connecting, I'll go ahead and do that. So some folks had some trouble loading up the file even locally in Excel. Uh, Actually, yeah, okay, so now we're connected. We're here on the lab machine, and now that I have those permissions set up, if I, let's go ahead into Jmp. Okay, so we'll do the same thing as before. I'll just delete this here because I had it open before, but I'm just gonna make it fresh. Okay, so now when I come here to this open data file part of the Explorer, if I go to this PC, now I have this additional option here. This wasn't here before. This is the name of my local computer, and I'll even show you if I come here to a command prompt. So this is my actual laptop now, not the virtual machine. And I type host name. So see, it's management P77124 272, and that's what it says there. So this is my laptop's drive that's now available to this remote machine. Okay, so we're going to be, you know, we're going to be connected to the remote machine, but to the remote machine, our local drive is a remote drive. So, but if I double click on that, now notice it takes a while for this list to populate, and that's just because it does have to communicate over the network to get this listing. So I put it here under text data sets, and so this is the women's clothes reviews clean, and I'll click on open here. Now this will take a while because not only does it have to um, open up the data file and ship it over the network, which is what it's doing now. It also has to import all of that into all of those data rows, the 23,000 data rows, into Jmp. And as Jmp does that, it actually deduces data types for all of the different columns. And so it does all of this neat stuff to make the data explorable. And so it's gonna have to go through two processes while it does that. Okay, so it's now shipped that the actual text data file over, and so now is when it's actually pulling the data into the memory and putting it into a structure that Jmp can understand. So we'll just give it a couple more minutes here. So see, we're up to 15,000 rows already. This is big data. This is not huge data, but this is a good deal of data. We'll see exactly how big in a minute when we look at word counts. But okay, so now the data is in here. It looks a lot like when you pulled it into Excel. The columns look the same, but if you look over here on in this left column, you can see these symbols mean that Jmp understands these as different data types. So for example, age, because it's got that notice that age and title have two different icons next to them, and that's because it discovered that age, and if I go to column info here, that it's a numeric and continuous variable. Okay. In 333, we go over all these data types. And in this case, you see that it's a character and a nominal. Okay, so that's what the title is. Okay, but we have in this lab, you're going to be doing a few things, but it comes down to the essence of it is that we're going to be using the capabilities of Jmp to look at what this text looks like. So if you come up here to Analyze, and then come down to Text Explorer, if we click over here on Text Clean, that's what I called it, because after I stripped out all of the non-printable characters, and I click on here for text columns. So I'm basically pushing this over here and saying, okay, this is the column that has the text I want analyzed in it. And so notice down here, before we launch this analyzer, you see it gives us a few options that we can select here. One of which is, so it's going to pull out words and phrases, and it's going to look at phrases of a maximum of 4. 3-word phrases, the research kind of shows that that's kind of the maximum you can get any kind of use out of. Notice also that we talked a little bit about stemming, that is chopping off the end of words so that we can keep different conjugations of the same word and count them as the same word. I'm just going to leave it at no stemming for now, and we'll just keep the rest of the options the same, and I click OK. And so now it goes through all of that text, and it comes up with this nice, neat distribution here for you. Okay, so this first term here, it's a kind of strange encoding here, but what this means is that the token that it found the most of is the exclamation point. Okay, but then, so this is telling you that there were 12,649 exclamation points in these 23,000 reviews. Okay, so, and then this gives you the word and the count, and so it sorts it in descending order of frequency. So you'll see that the top term in this data set is dress, love, size, top, fit, like, wear, and so on. For some reason, 5 is a pretty frequent term, and why would this be? Well, Jmp lets you right-click on the number and then actually show text, and it will go through and find all of those instances of 5 in the text and then show you where they are. So here we have, okay, so it turns out that the reason 5 appears so often is because most women are 5 foot something, and they seem to mention their height here a lot. So 5'3", 5'3", 5'8", 5'2", 5'7". Okay, so that's why 5 is such a frequently occurring token. And notice that so it's got the terms over here and the phrases over here, and it shows you that the phrase "true to size" is the most frequently occurring phrase, 2 or 3 word phrase, and it occurred 1,300 times. And also these phrases 5'4", incidentally, that appears to be like the mode of women's heights, 5'4". Looks great, love this dress, well made, fits perfectly, dress, exclamation point, 5'3", 5'5", 5'2", love this top, usual size. So one thing that we can conclude from this, why do we care about this word distribution? We might just make the observation that what would matter to these customers, it seems to be that fit is the overriding concern here. Notice that we've got size and fit and reference to a height and small and little. I guess flattering is not really the same, but true to size, fit perfectly. So we can see that across the board, there seems to be an overriding interest in how something fits as like a major criteria for its quality. Up here, this gives you some kind of summary statistics of the data set as a whole. This number of terms means that there were 15,500 different unique words. But then, so this number of cases just means the number of documents or the number of rows. So we had 23,000 reviews. And this is interesting. Notice that the total number of tokens, that is the total number of words and punctuation, is 1.3 million. So we had 1.3 million words, but only 15,000 of them were unique. Okay, so in the English language, we tend to use a small number of words very, very frequently. And you can see that we've got the word dress is 10,000 times, and love and size and top, these are these over 5,000 times each. But a lot of words, let's see with this, let me scroll down. You see this tail, most of the words on this list only appeared once. Okay, once, twice, okay. All right, and so that means, so tokens per case, this means that there were about 59 words in each different review, okay? And so the other thing that you're going to be asked to do is to save the document term matrix, and there are instructions for that. So I'm not going to run through the whole thing here, but what this will let you do, a document term matrix puts it'll add onto the back of your data set a bunch of columns, one for each word, and it will tell how many times that word appears in that review. And so once you do the regression on the star rating, what you're doing is you're seeing, well, how much weight does this particular word have on predicting the star rating? Okay, so we're doing kind of like an analysis of what people care about and how it determines the rating that they give, much like the one that we saw done in the hotel review study. Okay. All right, so that's a little bit, hopefully that gets you over some technical hurdles for doing this lab. The only other thing, some folks ran into trouble here. So now I'm not on the remote machine anymore. This is just my local laptop. I've got Excel open here, and when I want to go and find that file that I downloaded, the text review file, and I go to Browse, and I'll come here again to my where I downloaded it, which is in my text data sets. Whoops. So when I come to this folder here, it doesn't show up, and that's just because this filter here is telling Excel to only look for Excel files. That's kind of an obnoxious default, but that's how they do it. So if I say show all files, all of a sudden it's there, and then I can open it up. And then it has to go through some steps. So this is a text tab delimited format, so it's not an Excel file. So it's got to do some, you know, deduction about the delimiters between uh, the, the columns and so forth. Okay. And so there's the data set again. This time it's in Excel. And so the first part of the lab is just kind of getting at what you can do with Excel. Excel doesn't have a neat text analyzer the way Jmp does, so we're limited, but we can do a lot of text mining or a lot of data mining with Excel. And one of the things I'm asking you to do, for example, is to just find out how the star ratings are distributed. Okay, do we have a lot of ones and twos, or do we mostly threes? Is it normally distributed? It's not normally distributed. It never is with 1 through 5. So how do we determine this? Well, we can just do insert and pivot table. And if you haven't learned about pivot tables, they're a great thing to learn, for data mining, but then also just for any kind of general business analysis. Of your Excel skills are not complete without pivot tables. Okay, so then you've got these 4 different boxes that you can drag these variables into. And since we're interested in ratings, we want to have a row for each rating. Okay, so each unique rating it made a row for, and then what we want to have is we're going to drag the rating over again. And then I showed this in class, but just to remind you, we'll click on there and make it a count rather than a sum. So this gives us the count of the number of 5 stars, 4 stars, 3 stars, etc. So if I were to come here and sort this, let's see, pivot tables are a bit weird with the sorting. Let's see. Okay. Okay, so there, finally got it. So you can see that we have by far, 5 stars is the most frequent value. 13,000 of them, 5,000 4 stars, and only 842 1 stars. Okay, so a data set of 23,000 reviews, and only a small number, less than 1,000, were only 1 stars. Okay. So that's roughly how a pivot table works. You can play with it and do some more things. Another thing I'm asking you to do is to find the correlation between a couple of variables. So we might want to know, okay, well, this is the rating column, and here's the person's age. So you might say, well, do older people tend to give higher ratings? So you want to see if there's a correlation. Or you might see, okay, so this is the star rating, and this is the number of people who have said, okay, this is a helpful review. And so I can see just by inspection that these really high reviews, like these 5-star reviews tend to only have a couple of votes. So this 3-star one has 14 votes, and this 4-star one has 14 votes. So let's see if there's a correlation between the star rating and the helpfulness votes, or the positive feedback. So one way you can do that, here's a little bit of a trick for selection that'll help you with these long data sets. If you come over to the first ID column and do Control down, you'll see where the last row is, and we see it's 23,487. And I'm just going to write that down, 23,487. So that'll help me so that I don't have to keep clicking and dragging and selecting these sets. That'll help me create this. So I'm just going to do Control up, back up to the top here. Control up. There we go. Okay. So I want to know the correlation between this column, okay, this column, and this column. Okay, so I'm going to do CORREL for correlation. And then, so this is going to be F2 to 23,487. 23,487. Okay. And H2 to H 23,487. Okay. And I see that it's not a very large correlation, but there is a small correlation that and it's a negative correlation. Okay, so there's a weak relationship such that the lower the star rating, the more helpful people find it. And this is kind of a general principle with reviews. There's a negativity bias. Okay, so so there's about pivot tables and about how to do functions in Excel. I hope you're fairly comfortable with Excel by this point. Okay, well, hopefully that gets you past a couple of the technical issues that got in the way. And so over the weekend, go ahead and do your best to get as far on the lab as you can. I'll give you some time in class on Tuesday, but I do want to make sure that everybody's at least to the point where they have launched the Text Explorer in Jump and have done at least a couple of the pivot tables in Excel. Okay? All right. Let me know if you have any questions over the weekend, and I'll see you on Tuesday.